Right, check your answers here. Wherever the approach to infinity, usually we use that when approach infinity, divide the numerator and denominator highest power of the value in that problem. So in this case, what the highest power for, if you use n for infinity, we have 4 to the power n, 5 to the power n, 6 to the power n. So 6 is the largest base. The power of n also biggest value, right? What happens if you apply straightly what is power infinity? 10 to the power infinity 0. Any power infinity 0, right? So here 0, 0, 0, 0, all 0. Meaningless form. They have use another method to find. So highest power is 6 to the power n. The numerator and denominator divide by the 6 to the power n. So 8 to the power minus 2, 4 to the power n, divide by 6 to the power n, minus 9 to the power minus 3, 5 to the power n, over 6 to the power n, right? Plus here 10 to the power 4, 6 cancel, right, when you divide up and down. So we divide here 2 to the power minus 10 into 2 to the power n over 6 to the power n. Simple question, but look like different ideas. That's why just look like different format. To the power minus 9 to the power n over 6 to the power n plus 2 to the power 8, 6 to the power n. Let's divide if we cancel divide, right? The answer is provided, show that answer, okay? Now see this one, 8 to the power minus 2. Can I take this to whatever 4 over 6 to the power completely n? Okay. Here 9 to the power minus 3. Here what? 5 over 6 completely power n plus 10 to the power 4. Okay, that over here what? 2 to the power minus 10. Here 2 over 6 completely power n. The same here, 2 to the power minus 9. 3 over 6 power n plus 2 to the power 8. So check the answer. Any power, any base is a real number, power is infinity, answer is 0, right? This is 0 minus 0, 10 to the power 4 over 0 minus 0 plus 2 to the power 8. So it's the answer, check there, the answer is a 5 to the power 4 cut by 2 to the power here 8, 2 to the power 8, power 6 to the power n, s to the power 8, okay. So convert to common basis, power is 4, so this 10 to the power 4. If you write 4 here, 2 square. 2 square power 4. That is 4, here 10 cut by 2. So 5 over 2, the power 4, completely power is 4, right? That's my question 67. Next check will be the problem 67. 67 problem. 68 question, 68 problem. Limit x approach to a, x square sine a minus a square sine x over x minus a, right? An important question. If you apply x for a, x approach to a, what is the answer? If you put x for a square sine a square sine a 0, below is 0, therefore it's called meaningless pattern. They have to rearrange into any other form. It was an important question. The ideas are important. If you break the first step, if you complete the first step successfully, then becomes simple question hereafter, right? That is hereafter simple case. So the method is limit x approach to a. This is x square. Can I write this? Minus a square plus a square. See the tricky of this problem, how to break the first part. The main important part is x square minus a square plus a square cancel. The original parts available, right? Into sine a minus a square sine x over x minus a. Okay? Hereafter, by removing the bracket, rearrange the given problem expression sine a x square times, right? Can I complete this part? X square minus a square sine a. X square minus a square sine a, is it okay? Plus a square sine a minus a square sine x. Okay, that pattern. Can I write separately this denominator? Common denominator I write separately. X minus a for the both. Now what? Think that can factorize x minus a, x plus a form, right? X minus a, x plus 4, that a, simplify that. Limit x approach to a, x minus a, x plus a, x minus a cancel, x plus a into x minus a. Here take the a square out, okay? Take the a square out and think what is inside. Sine a minus sine x. But we work many that this video, last video, many sine c minus sine d pattern. But that sine a minus sine x, sine c minus sine d form, right? That is 2 cos sine c minus sine d, 2 cos. Add the 2, write the half. Add the 2, write the half. Other one is sine. Subtract, write the half, okay? Subtract, write the half. Okay, that over x minus a. Here no matter about this general form. Now limit x approach to a. Here x plus a into sine a. Here we rearrange general form, right? A square, or is it 2? Oh, give it cos a plus x over 2. Okay. Here we write this pattern sine a minus x over 2. Then you need below what? A minus x by 2. Is it? Check with you. Sine theta over theta pattern, right? Sine theta over theta 4. Now check, is it okay everything? This part is right. Here a square okay. Cos okay. Sine okay. Here x minus a, but here a minus x. Therefore there's a minus problem. Can I say minus here? Minus, okay, minus. And this 2 is this 2, okay? Take up the 2 available. A minus a, everything is okay. Now write the limit answer. So x tends to a. So a 2a sine a here a square, put x for a plus a, 2a divided by 2a, cos a, this is 1, that is 1, right? So it's the answer, 2a sin a minus cos a square cos a, right? Right, next my question 69. Problem 69, limit x approach to minus 1, pi within square root cos inverse x completely square root over x plus 1 square root. Find the answer when this takes minus 1. If you apply, what is cos pi? Cos pi is minus 1. Therefore, you apply this, pi minus pi cancel, 0, will also 0. So one of the Miller's pattern, right? So think any mode of way, any mode. So I worked many question inverse problems earlier. So what the idea? Take cos inverse x as theta. Okay, cos inverse x, let say theta, and convert to all the problem in terms of theta or any t form, and you complete the answer. Let cos inverse x, it's a t, cos inverse x is t. Therefore, now full question convert to the t pattern. If x tends to minus 1, t tends to pi. Okay, cos pi is minus 1. Okay, cos pi is minus 1. Therefore, come to the problem, limit x minus 1 means t approach to pi, pi square root cos inverse x is t over what? What is x? Cos t, is it 1 plus cos t? 1 plus cos t, or cos t plus 1, right? Again apply the t for pi. Pi minus pi 0, minus 1 0. Numerator 0, denominator 0, you can't go ahead. So once again use, now think a new question. Think is it new problem and do the rest. Conjugate form because of square root. They are multiple up and down by numerator, denominator, conjugate of the numerator. So that is equal limit t tends to pi square root pi minus t over 1 plus cos t, right? Completely square into what? Root pi plus root t, okay? Over root pi plus root t. Okay? So now, what is that? Equal to limit. Wherever we use the conjugate pattern, no doubt there must be a definite for a factorization pattern, right? Some complex numbers, limit, some differentiation question, conjugate patterns. So what is that? Pi minus t over, can I write the 1 plus double angle sine, cos 2 theta, 1 minus 2 sine square theta. They are very useful. We change that 2 sine square, what is that? T by 2, okay. Cos 2 theta, 1 minus 2 sine square theta, that form, right? Over square root pi plus square root t. Okay, important question. So at the remaining part, therefore limit t approach to pi, pi minus t over square root 2 sine t by 2, no? Sine t by 2. Okay, sine t by 2. That side what? Square root pi plus square root t. Okay. Now think a model of sine theta over theta pattern or any other form to convert that. So here t by 2, there's no any other t only, there's no t, simple t, that is not available. Here sine t by 2, okay, but no t here, no t, therefore that's you can't go that pattern sine theta by 2 form. Therefore can I change this sine theta as cos form, you know, cos 90 minus theta or sine 90 minus form. Here this 1 plus cos t or 2 cos square theta is wrong. That is wrong. See, no, you can't take that chance. Try with I am practically teaching you, not I am acting or not editing my these views and or videos straightly like a live telecast, live YouTube channel video here, right? See, you can't work this, you can't work. See the problem come. Therefore, best thing convert to cos. The how one the one remove. You can't remove the one by this way, but it's cos 2 theta, 2 cos square theta minus 1. 2 cos square theta minus 1. Be careful, right? If you misuse, no answer. 2 cos square theta by 2 minus 1 plus 1, 0. Therefore, the way square root 2 cos t by 2. Important question, not chance for error. If you misuse the 0 marks. Now we change to the general form of trigonometric limit. T tends to pi, pi minus t. The sign available only chance for a trigonometric part. What is cos theta? Sine 90 minus theta. Sine 90 minus theta is cos theta. Okay. We write this sine pi by 2 minus theta by 2. Okay. It is cos. Okay. If you know clearly trigonometric basic rotational in the quadrants trigonometric chapter, right? Now rearrange this form. Limit t tends to pi. Can I write this 1 over square root 2 available? Sine, can I say pi minus t over 2. Then below without that sine part angle, okay. Sine theta over theta into root pi plus root t, right? Okay, now see that form. Check any other additional part. This is okay. This is okay. Root 2 available. Pi minus t is okay. This 2 is an additional part. Therefore, I multiple here 2 is it? And 2 cancel. Okay. Now write the answer 1 over. This 2 goes up. I think it's a 2 over. Okay. 2 over root 2 sine theta over theta 1. Okay. Sine theta over theta is 1, right? Into 1 into put t for pi. Pi 2 times square root pi is it? Yeah, but the answer is what? 2 cancel. A useful problem for any future papers, future exams. Is okay? Check with you. 1 over 2 times square root pi, right? That's the answer. This is my 69 question. My 70th question. Limit and approach to infinity square root n cube plus 2n square plus 1 plus fifth root n to the power 4 plus 1 over fourth root, right? Power 6, 2 and power 5 plus 2, and the useful question, fifth root n power 7 plus 3n cube plus 1. Find the answer when n approach to infinite, right? N tends to infinity. So we know that method is where the infinity comes. We should divide the highest power, all the powers or numerator, denominator, divide by the highest power of the n. So here what the highest power? Fifth root is the small part. 1 over 5 is the small answer. 1 over 4, the other greater. 1 over 5, smallest. Here square root is the biggest answer here. Square root, power 1/3, power 1/5, all reducing part. Okay. Therefore here the highest power is actually n cube. Inside the root is n cube. If you take outside the root, what happened? The answer n to the power 3 over 2 is it? N to the power 3 over 2 outside. Therefore the idea, numerator, denominator, both divide by n to the power 3 over 2. Inside that, above and below, divide by n to the power 3 over 2. According to that, take this part inside the roots, right? Therefore, see the method. Here n cube. So outside n to the power 3 over 2, if you put inside the root, it becomes a square of that. Therefore, it becomes cancel. Okay, 1 n cube. If you write a square, that's 3. That's n cube, right? N cube plus 2n square n cube plus 1 over n cube. So I hope you understood this. Inside the root, divide by n cube. That means outside 3 over 2. If you take this inside the square, what happened? It is square, no? It is square. So 2 cancel, n cube available. Okay. Right. Plus, this is fifth root. N to the power 4. Here. N to the power 3 over 2. Take inside the fifth root, it becomes what? Like this. Okay. It becomes like that. Or n to the power 15 over 2 like that. Okay. You can write that one. N to the power 3 over 2 to the power 5, right? 1 over n to the power 3 over 2 completely power 5. Check properly. Over 4. How the 4? If you n to the power 3 over 2 put inside the fourth root, it becomes 4, right? Therefore, here 4. N to the power 6 divide by n to the power 3 over 2 completely power 4. Okay? Plus 2n to the power 5 divide by n to the power 3 over 2 power 4. At last 2 over n to the power 3 over 2 power 4. Same the other last fraction, last expression. Fifth root. As I mentioned here, like divide n to the power 7 divide by n to the power 3 over 2 power 5 plus 3n cube divide n to the power 3 over 2 power 5 plus 1 over n to the power 3 over 2 power 5, right? Now simplify, get the answer. So what happened, this is square root. Here 1, that's why we divide 1 plus 2 over n plus 1 over n cube. N approach to infinity, right? And plus here fifth root. Here what happened is actually here power 4, this is 15 over 2 like, or 7 over 2, 7.5, right? N to the power 4 here. N to the power 4 below n to the power 15 something. There's a value below n, right? 1 over. You can check n to the power something, right? N to the power, there's a no max becomes 0 later, or 0. And plus here 1 over n to the power value, n to the power value. And here what, 4th root. A similar fashion, 1 here the biggest power, here 12, so here 1, this is 1, okay? This is 1, this is 1, right? Here 12, 6 here the highest power, 2 over n, check will be 2 over n, okay? Plus that is 2 over n to the power 6, check this, no matter is below n, no matter it becomes 0, 1 over infinity becomes 0, no matter whatever, check value. Plus there 5th root, they are all the same, 1 over something, right, n to the power something there, and that is 3 over n to the power value plus 1 over n to the power value. Okay, I not mark the value, try complete it there, a value whatever. And now put n for infinity, here 1 plus 0 plus 0, 1 plus 0. Therefore, answer a simple question, but you'll know how to work such a problem. Divide by highest power, numerator and denominator, right? See, next 71, problem number 71, important question. Limit a approach to 0, e to the power n log x plus ln. Ln also, you know, logarithm base e, no? Ln mean exponential function, minus e to the power n ln x over a. The very first video I mentioned the syllabus, there's no logarithm limits, there's no e to the power limits, right? There's no inverse limit also, but we can convert to inverse for a sine theta over theta or tan theta over theta or any applicable method of trigonometry. Similarly here this question, no, there's no straightly e problem not available in the syllabus. So, but we can work this through our traditional limit theorem. We can convert to that what we learned the algebraic limit or trigonometric limit part. Okay, this is algebraic part. So we can change into something part. Okay, see that I will take this power. Let y equal n ln x plus a. Very useful question. Think you will convert to any other form and do the rest. That is applicable, not straightly, because e we have series, e to the power x, there is a series. Logarithm we have a series, we have graph for logarithm, log x graphs. So I took that is y, right? Or we can write this one, y equal, what is ln mean? Base is e, right? Logarithm, if I say log, say base is e, okay? Next, y equal logarithm base e x plus a. You know, logarithm rule show as a power. Show as a power, right? Can be show as a power. This is logarithm part. So try to show the indices pattern, power pattern. Therefore, y to the power e, is it? Y to the power, oh, what that? E to the power y. E to the power y equal to what? X plus a to the power n. This is the indices method, right? Logarithm form, indices pattern. Okay. Now see, similar fashion, I will take this as z, and do the rest. So next one, let z equal n log x, n log x, or otherwise z equal n logarithm notation base easy, or otherwise z equal what? Logarithm x to the power z. Alright, earlier part convert to the indices form. This is logarithm form. Convert to indices form. How that? Therefore, e to the power z equal x to the power z. Okay, is it okay? Check will you? E to the power z equal x to the power that is that form, right? N, I missed the n here, n. Okay, right, now see the question. Therefore, limit x approach to a, e to the power, this I took as y, minus e to the power, this I took as z, right? Over a. Okay, further thing that limit x approach to a, e to the power, what is y? E to the power y, e to the power y is what? X plus a to the power n, e to the power z is what? X to the power n, below what? A. Can I write the a like this? X plus a minus x. Okay, without the power, no? Straight algebraic theorem of limit. With the power, below without the power. So write the straight answer, n a to the power n minus 1. The answer is n a to the power n minus 1. Okay, therefore the answer n x to the power n minus 1 is the answer. Therefore remember that there is no direct e problem in limits. You can see all nearly 50 years past exam, that's not available. No logarithm limit, no sine inverse. But something like this we can convert to the other pattern, hence complete the solution. That's the idea, right? Okay, next my 72nd question. Second problem. Limit x approach to 0, x sine x over 2 sine square 3x minus x square cos x. It's a simple question. You can work. We have many problems. I work nearly 70. Too much problem this is. But you will practice like that. Every solution I shown, you will practice yourself once again. Maybe sometimes my too long or something too short. I hope that's correct methods. You decide that and do the rest. So try here what happened for x4 0, above 0, below 0, no chance. But you have idea for sine theta over theta pattern. So can I divide by x square first? Your first step, divide up and down by x square. Numerator and denominator divide by x square. Sine x over 1 over, I divide by x square, right? 2 over x square sine square 3x minus cos x. I divide by x square. Okay, so next word, limit x approach to 0. Write the general pattern of trigonometry, sine x over x. That's okay. And here what? There's a 2 sine 3x over 3x, but a square, therefore completely square minus cos x. Now check any other alteration, additional parts available here. Check, will you? 2 is okay, x square okay, 9, there's a 9, no 9, so multiply 9, okay, multiply 9. Now apply the answer, sin theta over theta 1, here what, 18 into 1 minus cos naught 1, so answer 1 over 17, right? 1 over 17 is the answer. Next problem 73. Show that, right, the question, show that limit h approach to 0, 4e to the power h minus 4 minus 4h minus 2h square over what? H cube, right? Equal 2/3. So we will show the answer is this. So as I mentioned many times, there is no e to the power problem directly. If so, there is a question. They must tell about the series of e. What do you mean e? In the earlier Macular's theorem, many transformations that's there in the earlier syllabuses. That day we know what is e, clearly everybody knows what is e. In the differentiation, when we differentiate the e, before go to the first principle method of differentiating e, we explain to the students what is e. So I show here, actually e to the power x is like this, 1 x over factorial 1 plus x square over factorial 2 plus x cube over factorial 3 up to infinity term, right? That's the meaning of e to the power x. Then e to the power y means put x for y. E to the power 5, put x for 5. E to the power 2, put x for 2. There's a values. So I come to that pattern therefore. So 4 into h for 0, right? Now what is e to the power h? Write that. 1 plus h over factorial 1 plus h square over factorial 2 plus h cube over factorial 3 and so on, right? Only that is new, others are ordinary methods. Simplify further. Minus 4 minus 4h minus 2h square, everything divided by h cube. The problem is h tends to 0. Now see, if you multiply by the 4 bracket, 1 times 4, 4, here 4 cancel, okay? But the remaining with the 4, here h square. You know factorial 2 means what? 2 into 1, that is 2. H cube. But factorial 3 into 2 into 1, that is 6, okay? And so it's so on, some values available, okay? So 4 cancel, minus 4h minus 2h square over what? H cube. Okay. Now see, if again further simplify the bracket, 4h cancel, multiply 4 here, 2h square minus 2h square cancel, but the remaining hereafter 4h cube over 6 below h cube plus h to the power 4 factorial 4 h to the power 5 factorial 5, like that. Okay, it's continuous. This everything become infinity. That h4 0 is 0. Here this part is 0. All parts are 0. H cube cancel. Answer is 4 over 6. 4 2/3, right? Oh, answer is 2/3. This part's a 0. 0 over 4, 0 over 5, like that. That is 0, right? This is my question 73rd. See question 74. Limit x approach to 0 sine cos x minus cos 5x over square root 1 plus x square minus 1. See, an important question. Only sine, not sine x, right? Only sine part. Sine, the angle is inside. The angle is inside the angle, this part, sine. Sine theta. So straightly there's a pattern, sine theta over theta. So we rearrange that pattern, convert to the problem that. Rearrange, go to the answer, sine theta over theta pattern, right? Sine theta over theta form. So limit x approach to 0 sine cos x minus cos 5x. Okay. Then what is below without the sign? Sine theta over theta form, right? Check, is it okay? Sine theta over theta form. Sine theta over theta form. And what the additional part, rearrange that part. This is, I mentioned, not in the original problem. Divide by that, therefore multiple to remove that. Cos x minus cos 5x over square root 1 plus x square minus 1, right? Now do this one. This answer is 1 sine theta over theta 1 when x 0 means cos theta 1 minus 1 0, right? Cos naught is 1. Okay, therefore we should rearrange this pattern for our ordinary method. You know, cos c minus cos d. Cos c minus cos d form. So limit x approach to 0 sine cos x minus cos 5x over cos x minus cos 5x, right? Use the trigonometry cos c minus cos d, last factor formula. What is cos c minus cos d? 2 sine, at the 2, 6 mean divided by 3, divided by 2, 3x. Cos c minus cos d, 2 sine at the 2, 6x divided by 2, 3x. Again sine, this minus that, 4x divided by 2, 2x. Below, can I use the factorization pattern? Use that conjugates, otherwise you can't do. Conjugates multiple square root 1 plus x square minus 1 plus 1 up and down, right? 1 plus x square plus 1 multiple numerator and denominator, okay? So limit, long problem, long work, but easy question, you will practice step by step. Sine cos x minus cos 5x over cos x minus cos 5x is part of answer. So here we rearrange the general form. Sine 3x, then unit below 3x, sine theta over theta. Here sine 2x below 2x. Here what? Nice question, right? So a problem for expecting any exams, for any exam is final papers, term papers, school papers, provincial papers. Now check whether it's correct. This is available, okay. Sine 3x okay, sine 2x okay. And this 2 here, okay. This 2 is here. You can write that 2, is it okay? This goes up, no. This 2 we can, this 2 available. This 2 needed, okay, right. Here see if using this 2 factorization 1 plus x square minus 1 with the root 1 plus x square plus 1. What then if we multiply this 2? 1 plus x square minus 1. 1 cancel. X square remaining. X into x, x square, that is okay. That is okay, right? Everything okay. There is a 6. 3 times to 6 available. There is no 6 in the original problem. Therefore, I multiply the 6. Check value, is it okay? That's the answer. Now apply the limit theorems. Sin theta over theta 1. Here 2. Sin theta over theta 1. Again 1. Put x4 naught. 1, 1, 2. At last 6. So what the answer? 24. Solution 24, right? Important question. X24 is the answer. Next, my question 75. Limit x approach to 1 cos pi x plus sine pi by 2x over x minus 1 square. Show that answer, show that, right? Show that answer. So simplify, try will that you on. I will show the other video, this question and some more.